Okay, this video we are going to talk about the numbers that are divisible by 2 by 2. See, all the numbers that the last digit is even number. Okay, like 4, 6, 2. Also 0. You know, if there is a number the last digit is 0, these are all even number. 2, 4, 6, 8, and odd number are 3, 5, 7, 9, and these are the odd numbers. So we're going to know that what number, like you say, somebody say 120, 126. Is it divisible? See, the last digit even number, 4. So we can divide it by 2. See, it's going to be divided by 2, and this one is divided by 2, both of them. You know, when you want to simplify a fraction, both denominator and numerator, they both got to be divided by that number. We cannot say to simplify, just divide this one by 2 and then the other one. This is wrong. Like you say, this is going to be 63 divided by 2 is going to be 63, and we have to divide this one by 2. Divide by 2 is going to be 63. Divide this, we got to divide this one by 2. So divided by 2 is 1, is 63. See, the last digit, if we say 150, this also we can divide it by 2, no remainder, you know, divisible. It's going to be 75. If it's 75.5, like 151 divided by 2, that's going to be is 75.1 or something else, you know. It's not like here is this is not it has a decimal in it, so no remainder. Beside those numbers that divisible by 2, that has no remainder, but this one by 2 is 75, like 0.5, right? So it is not divisible by 2. So what I'm trying to say, we are going to find out that what numbers are divisible by 2. So either the last digit is even number or 0. Like you say 1980 is divisible by 2 because it has 0 at the end, and 183 is not divisible by 2 because it's odd number at the end, not divisible by 2. Okay, now we learned what number. Like if you say 128, you want to break it down. Okay, you say divided by 2 is going to be 64, divided by 2, 32, divided by 2, 16, divided by 2, 8, divided by 2, 4, divided by 2 is 2, and divided by 2 is 1. So actually 1, 2, 3, 4, 5, 6, 7 means 2 to the power of 7 is equal to 128. Okay, you can, I can show it to you on the calculator. We turn this on, clear 2 to the power of 7 is equal to 128. So we break it down. So all these numbers are divisible by 2 because at the end of it you see that it's even number. Like we say 2 to the power of 7 is 7 times. 7 times you multiply 2. These are, it's going to be 128. 7 times 6, 3, 6, 1, 7, 7. So, if somebody say, do you want to break it down, write it in terms of exponent, the number in the exponent, you write it like that, this. Now let's talk about those numbers that divisible by 3. See, you know that the number like 1 times 3 is equal to 3, 1 times 2 is equal, I'm sorry, 2 times 3 is equal to 6, 3 times 3 is equal to 9 and 12 and so on. All these numbers are divisible by 3. 18, 21, 24, 27. This 27 is divisible by 3 because if you divide 27 by 3 you're going to get 9, or you can write, as I said, you can write it this way, that 9 times 3 is equal to 27, okay? And if you divide 27 by 9, you're going to get 3, or 27 divided by 3 is going to be 9. So all divisible, see, 27 also divisible by 9. You're going to get 3. So all the numbers that you see are divisible. But somebody asks you, how do you know that 24 is divisible by 4? You know what to do. You add these two numbers. You say 24 divided by 3. You add these two numbers. You say 2 plus 4 is going to be 6. Okay? So 6 is divisible by 3. So we can say we can divide this one by 3 is going to be 8. And this one is going to be 8. So we divide both numerator and denominator by 3. You will get the answer is going to be 8. So you add those. So you add digits to see if they are divisible by 3. Like I said, another example, 1, 2, 6. This is divisible by 3 because you add these together. 6 plus 2 is 8. 1 is going to be 9. 9 we can divide 9. 1 plus 2 plus 6 is equal to 9. So 9 is divisible by 3. So 126 is divisible by 3. So this way you can find out what numbers are divisible by 3. I'll give you another example, and then it says 5, 6, 4. This is, we can divide this one by 2, okay? We want to know what numbers are divisible by 2. But by this number we can divide this either by 2 or 3. Why 3? Because if you add 6 plus 4 is 10, 10 plus 5 is going to be 15. 15 is divisible by 3. Is equal to 5. So what I mean, 15, you're adding this number, you are going to get divisible by 3 and 2. If you want to divide it by 3, 564 is going to be 564 divided by 3 is equal to 188. So this number is also divisible by 2 and also divisible by 3. So add the digits. Add this digit to see if they are divisible by 3. Now talk about the numbers that talk about those numbers that divisible by 5. See, all the numbers that divisible by 5, the last digit, we're talking about last digit like that. Digit. Like it's 565. The last digit is 5. So this one can be divided by 5. Or the last digit is either 0 or 5. We can divide it by 5. Like this one. You know, you find it in the calculator, you turn it on, and you say 565 divided by 5 equal 113. Okay? So another example, it's the same, it's 560, like for example. We can divide it by 5 too, no remainder. It's divisible by 5. So the last digit either 0 or 5. 0 or 5. The last digit either word. Even number, and the last digit is even number, you can divide it by 2. This also divided by 2 because the last digit is 0. If you divide this one by 2, 280, right? We can divide this one by 2. We got 280. So all the what I'm trying to say is if the last digit is even, you can divide it by 2. Adding the digit together. Add digits, like I said, 1, 5, 6, 9. See if the divisible by, it doesn't mean at the end. Okay, let's these two numbers 6, 8, and we want to divide it by 3. We see, add these number together, 9, 6, 15, 15 plus 5, 20, 21. 21 is divisible by 3, so 1569 is can be divisible by 3 and no remainder. But this one, if we add together 8, 6, 14, 14 plus 5, 19, the addition of that is going to be 20. That's what is 21. We cannot divide this one by 3. It has remainder. Okay? So the last 3 digits. Now we are gonna simplify. Give you some example to simplify these a fraction. 589 divided by, you see, 17 plus 5 is 22. It's not going to be divisible by 3. Okay, let's change this one to 9, 17, 17. If we add this number, 9, 8, 17, 22, 27, 7, 5, 12, 12 plus 8, 20, 29, this, we can divide this one by 3 because addition of these number. Now, we write a number here, 126. See, this one is divisible by 3. 6 plus 2, 8, 9. So we can divide both sides, divide by 3. Divide by 3. What is going to be the answer? Seven, 5, 8, 9. 17. No, 27. I'm sorry. It's going to be 7. Okay. See, if we add two together, 8 plus 7 plus 8, 15, 20, 27. So 27 is divisible by 3. So we can divide this one by 3. So what we do, 75, 87 divided by 3 is going to be 25, 29. And we can divide this one by 3. See, okay, let me explain this one. Also, is pretty much, okay, let me finish this one first. 42, this is going to be 42. Divided by 3 is going to be 42. We say this is 4 plus 2 is 6. 9, 2, 11, 11, 5, 16, plus 2, 18. We still can say we can divide both sides by 3. What's going to be? Okay. If you divide 2,529 divided by 3 is 843, and this one by 3 it's going to be 14. Now to see if we can simplify more. 8 plus 3 plus 4 is 7, 7 is 15. See, 15 can be divided by 3. Yeah, we can do it by 3. But this one we cannot do it. This 14 we cannot divide it by 3. I mean, it's not divisible by 3 because it has remainder. You know, it has remainder. What I'm trying to say, if 14 divided by 3 is going to be 14 divided by 3 is going to be 4.666, and continues. We can write this one as a fraction, you know, because the number is been repeated, and so this is, we cannot simplify more than that. So this is the way of how to simplify these fractions. You know, there is something that we should talk about it in when there is a fraction. When there is a fraction, we talked about it like 1 over 4 times 1 over 4. It means 1 over 4 is to the power of 2. Why? What is like that? It means that 2 means 1 over 4, 1/4 multiplied 2 times. 1/4 times 1/4 1 over 16. So the answer is 1 over 16 because we multiply the numerator together and denominator together. 1 times 1 is going to be 1, 4 times 4 is going to be 16. How about if we write this one as so 1 over 4 times 3, what does that mean? It means 1 4 times 1 4, 1 times 1 4, 1 over 4 is going to be 1 over 64. This is 1 over 16. So how about, let's talk about the negative numbers too. This is 1 over 4 times minus 1 over 4. Then minus 1 over 4. What is going to be? 1 minus, if you multiply this one, plus 1 over 4, minus 1 over 4, is going to be minus 1 over 16. And then you times, multiply, on 1 over 4. See, these negative numbers, if we multiply, negative times negative is going to be positive. So positive 1 times 8, 64. This is going to be 1 over 64. But if we, how about if we had another 1 over 4, 1/4, you know, you want to find it. This one times this one is going to be positive 1 over 16, and then minus 1 over 4 is equal to minus 1 over 64. Minus. The same thing happened in division. If you have minus 5 divided by 2, it's going to be minus 2.5, okay? Just sure. But if this is minus 5 and this is minus 3, is equal to 5 over 3. The minus cancels out. But when you divide minus by plus, it's going to be minus. It's the same as if you have a positive number here and the numerator is positive integer and negative, the denominator is negative integer, is going to be minus 5 over 2. The same rule applies, you know, for division, or both of them are positive for sure. You know, if positive 5 divided positive 5 is going to be 1. Okay. So how about the negative? We want to talk about the negative negative exponent. Like, you know that if you say x to the power of minus 1, what it means? It means you just invert it. You say, you bring the you write the 1 here and x here, and so the power is 1. We don't write it. So we will write 1 over x. How about x is minus 2? Means 1 over 2. You write everything like this, but change it to the positive exponent. We do this way. This is actually 1 over x2. There are, if you have 6 that's right, 6 y to the power of minus 3. What is that? Okay, we write the 6 1 there. Y to the power of minus 3 is y to the power of 3 is actually 6 over y over 3. And we can write it this way. We can write 6 y, bring it to numerator, it will be minus 3. So these are the things that we should know about it. So I give you, you know, the is equal if this one a times a to the power of 2 times to the power of 3. What's the result? See, what you do, you add these together. The exponent will add together 7 plus 2 plus 1. This is exponent is 1. So it's actually a to the power of 6. You add these exponent together, right? You write it like this. See, you were talking about x times x, or let me show it this way, the multiplication. This is multiplication. It's going to be x to the power of 3. You add these together. So always, you know, add, if you have this base is the same, you add the exponent together. How about another example? Z to power of 2, and this one makes it a little bit more complicated. Z to the power of minus 4. What is going to be the result? It's going to be z, and then we write here 2 minus 4. Is it going to be z to the power of minus 2? Okay. How about z to the power of 3 plus times. This is going to be multiplication. If you can do this, is just because of the multiplication. It plus in between, no way. It's not going to work that way. So z to the power of 3 times to z power of, then let's write this one, minus 1 minus 2 times z minus 4. What's going to be the result? Minus 4 minus 2 minus 1 is going to be minus 7, which is, you can write it like this, 1 over z to the power of 7. So I want you to know the mechanic of this. If we multiply this exponent, the numbers, or these are unknown number that we can talk about, or anything else, something else. Let's talk about 2 times 2 times 2. This is plus 5 minus 2 minus 4 is going to be 2 minus 4 minus 2 minus 6 minus plus 5 is going to be minus 1, and we can write it this way, 1 over 2. Okay, I think that's going to be, you know, when you this got to be multiplication. No, you say the 2 plus 2 plus 2 to the power of minus 4 minus 2. We cannot write it like this. We see, it has to be multiplication in order to do this. Add these exponents together. Okay, think we see we are going to make you prepared for actually IT engineering, because in any engineering courses you have to know these college algebra, and this is the introduction to college algebra.